Hi everyone, my name is Mike Hansen and I'm an enterprise customer engineer at Google Cloud. Today we'll be discussing CDN policies on Media CDN and how you can use them to deliver and cache your content. Let's get started. Before we jump into Media CDN, let's take a moment to look at the three fundamental components that make up Media CDN. There's the service, which is what contains your overall CDN configuration settings, the origin, which is the location that Media CDN will use to fetch your content, and key sets, which are used to secure access to your content when signing or tokenizing requests. Today, we'll be focusing on CDN policies, which are part of the Media CDN service. Now that we understand the high-level structure of Media CDN, let's dig into the details. If you've seen our host and route rule video, this tree should look familiar. For those that haven't, this is the basic structure when defining Media CDN rules to route your content. At the top, we have our host rule, which is the public-facing hostname that Media CDN listens for. Within a host rule, you'll find route rules, which are used to group URL paths via match rules that share a common origin and CDN settings. And within route rules are route actions and header actions. A route action is what allows you to apply URL rewrites, CORS policies, and CDN policies to your routes. Header actions allow you to manipulate request and response headers, and they'll be covered much more in depth in a separate video, so be sure to check that out. Today, we'll be focusing specifically on the CDN policy, which is a route action that's located within a route rule. A CDN policy is a specific kind of route action that can be applied to your route rules. It's a set of configuration settings that control how your content is cached, served, and delivered through Media CDN. These policies allow you to fine-tune the behavior of Media CDN to optimize performance, reduce latency, and manage your traffic effectively. It consists of three main components. There's cache modes and time to live values, or TTLs, cache keys, and negative caching. Let's dive into each of them. First, we'll start with cache modes. Cache modes provide different strategies that define how content is cached and served to end users. These modes determine how Media CDN decides to store and retrieve content from the cache, helping optimize performance, reduce latency, and manage origin server offload effectively. There are four to choose from. Cache all static is the default cache mode that's applied when you initially add a CDN policy to a route rule. This cache mode caches common static content such as images, videos, and audio files for a default period of 1 hour. The TTL is configurable. Force cache all will unconditionally cache successful responses, overriding any cache directive sent by an origin. Be careful with this mode as any private cache control directives sent by the origin will be ignored. Next is use origin headers, and it works exactly as the name implies. It directs Media CDN to honor valid cache control directives sent from the origin. Unlike cache all static, when using the use origin headers cache mode, there are no additional TTLs to set. And finally, bypass cache directs Media CDN to avoid serving any objects in cache, even if an object is already cached and matches the cache key of the object being requested. Next, let's talk about TTLs. TTL overrides allow you to specify how long your content should be cached by Media CDN. Depending on the cache mode that you select, there are three TTLs that can be configured. First is the client TTL. This lets you instruct the client's browser how long cached content should be considered fresh until revalidating upstream, which in this case would be Media CDN. Second is the default TTL. This is the CDN TTL. It allows you to specify the duration for how long objects are cached on Media CDN before being required to revalidate freshness with the origin. And finally, there's max TTL. This instructs Media CDN to revalidate content more often than specified by an origin header. For example, if the origin is setting the cache control max age to 1 year, but the max TTL on Media CDN is set to 1 day, Media CDN will ignore the origin's max age value and use the max TTL instead. Next up, let's talk about cache keys. Think of a cache key as a unique identifier for a piece of content stored in Media CDN. By default, the cache key includes the hostname, path, and all query parameters. This means that if someone requests the same image but with slightly different query parameters, Media CDN may treat them as separate requests and fetch the image from the origin multiple times. Let's use this example of two pictures of the same cat. These images are identical in every way. But if a marketing tag is appended as a query string, by default, Media CDN will treat these as two separate images. This can affect performance as well as your cache hit rate. To fix this, you can ignore the marketing tag query string, so Media CDN will serve the same image for both URLs, thus increasing your offload. Media CDN also allows you to fine-tune these identifiers. You can choose to ignore certain parameters that don't affect the content, or selectively include the ones that are needed to differentiate content. By carefully configuring cache keys, you can make sure Media CDN is storing and serving your content in the most efficient way possible. This leads to faster delivery for your end users and less strain on your servers. Finally, let's talk about another useful feature called negative caching. Imagine a user tries to access a page that doesn't exist on your website. Typically, that would result in a 404 not found error. Instead of the origin constantly handing out the same response, Media CDN can store that error response in its cache, lightening the load on your infrastructure for expected or unexpected issues. Media CDN gives you granular control over negative caching by allowing you to specify which error statuses you want to cache and for how long. This allows you to fine-tune your content delivery strategy, ensuring optimal performance even when things don't go as planned. Now that we've learned what the CDN policy is and its components, let's dive into a quick demo. In this demo, we'll review what cache modes are and how they work. We'll demonstrate how cache modes can affect the cacheability of an object, and we'll review how negative caching works. Let's get started. On my screen, I have a picture of a cat. This image is currently hosted on Google Cloud Storage, and we're using Media CDN as the proxy to fetch the image when the browser requests it. If we take a look at Chrome Developer Tools, we can see that there's a cache control header set to private with a max age of 0 seconds. This is important, so keep that in mind. We can also see some other caching headers like the etag, expires, and also a last modified header. In addition to the standard caching headers, we also see the server header, which shows Google Edge Cache, meaning the request and response are routing through Media CDN. And finally, I've added a custom dynamic header called CDN Cache Status to tell us whether the object was served from Media CDN's cache or not. For more details on how to configure custom headers, be sure to check out our header and route action video or review the documentation. As you can see, our CDN cache status value is showing uncacheable across 3 Media CDN nodes that the request routed through. This means that there is either no CDN policy configured yet, or the requested object does not meet Media CDN's cache eligibility requirements. If the object was served out of cache, we would see the word hit somewhere in the header value. Or, if the object was eligible for cache, but not actually found in the cache, we'd see the word miss. Since we haven't configured a CDN policy yet, we know that's the root cause for the uncacheable value. So let's go ahead and add one. Navigating back to our Media CDN configuration, we can see the 2 route rules that we've previously configured for HLS streams, as well as the catch-all rule. Since we're working with a URL path that doesn't match the first 2 HLS rules, the catch-all rule will be invoked. Remember that including a catch-all rule in a Media CDN configuration is a best practice. To add a CDN policy to a route rule, click on the pencil icon to edit the rule. Next, expand Advanced Configurations. Before we add a CDN policy, here's the custom dynamic header that I mentioned earlier. You'll notice that I'm setting the header name to CDN Cache Status with a value that uses the built-in CDN Cache Status variable. Let's close that up for now. Next, we'll click Add an Item under Route Actions and select CDN Policy. By default, we can see that the default cache mode of Cache All Static is selected. This will cache all eligible objects while still respecting any cache control headers sent from the origin. We can also see the client TTL, default TTL, and max TTL. The client TTL tells the browser how long to consider the object fresh in its cache. The default TTL is what dictates how long Media CDN will consider the object fresh with a default value of 1 hour. And the max TTL is used to enforce the maximum amount of seconds Media CDN should consider the object fresh, even if the origin is setting a higher cache control value. For this demo, let's set the client TTL to 5 minutes or 300 seconds, and we'll leave all other TTLs at their defaults. We'll click Done, then Save, and update our service. Now that our service is updated, let's head back over to our cat picture, refresh it, and take a look at our response headers to see what's changed. As we can see, not much of anything. CDN cache status is still uncacheable across the board, and cache control is still set to private with a max age of 0. But why? By default, the origin, which in this case is Google Cloud Storage, sets the cache control header to private with a 0 max age. And the cache all static cache mode that we set respects origin cache control headers instead of the default TTL that we set. So in this case, Media CDN is simply using the cache control value sent from GCS. So how can we override this? One option would be to modify the cache control settings on GCS itself. But instead, let's change our cache mode to Force Cache All and see how that affects the cacheability of the image. Why do we want to do this? Because Force Cache All will override any origin cache control settings that are being set. This effectively moves the caching decisions exclusively to Media CDN for this particular route rule. So let's navigate back to the same route rule we edited earlier, expand advanced configurations, and expand CDN policy. Now let's change the cache mode to force cache all. You'll notice that the max TTL input box has disappeared. This is because the force cache all cache mode ignores any cache directives from the origin, so it's no longer relevant. Let's go ahead and click Done, save, and then update our service once more. Now that our service has been updated, let's click back over to our image and look at the results. We can see immediately that the cache control header has now switched from private to public, and the max age is now set to 300 seconds, which is the same value as the client TTL that we set in the CDN policy. If we take a look at the CDN cache status header, there's a lot more interesting information there now. Instead of showing 3 uncacheable values, we now see lots of misses as it hopped through the various Media CDN nodes looking for the cached object. The 3 letters you see next to each miss are airport codes, indicating the general area of the Media CDN nodes that served all or part of the request. Since this was the first time I'm requesting the object, Media CDN has not yet filled its cache with the image, so the response was fetched from the origin. We know this because we don't see any hits in the header value. If we refresh once more, we now see there's a hit, which means that the object was served out of Media CDN's cache as expected. You'll also notice the age header is now present in the response. This indicates how long the object has remained in Media CDN's cache. Now that we know how to work with cache modes and TTLs, let's review how cache keys affect the cache hit ratio of an object. We can think of cache keys as a unique identifier for a piece of content stored in Media CDN. By default, the cache key includes the hostname, path, and all query parameters. Using the same cat image as we used for the CDN policy, we can refresh the image and see that we are still receiving a hit in the CDN cache status, and the age header has a value that's increased since it's been in cache for a couple more minutes now. But what happens if I add a query string to the end of the URL? Let's find out. I'll add the query string marketing tag with a value of 234 to the end of the URL and hit enter. So what happened? The image is exactly the same as before, but now I see the age header set to 0 and my CDN cache status header are all misses again. Let's change the value to 567 and see what happens. Again, age is set to 0 and CDN cache status contains all misses. By default, Media CDN includes all query strings and their values separately in its cache key. So because of the presence of the marketing tag query string, Media CDN considers this a new object even though it's the same exact image. This can seriously affect your cache hit rate since the marketing tag should have no effect on how the image is delivered or displayed to the end user. All users should see the same image regardless of the marketing tag. So how do we fix this? Let's head over to our Media CDN configuration and take a look. On the screen, we can see our route rules. Let's go ahead and edit our catch-all rule like we did before for cache modes and open up the CDN policy settings. Underneath the TTLs, we can see the section to modify the cache key. We can include the protocol, exclude all query strings, exclude the hostname, or be selective in what we include or exclude. In this case, we want to exclude the marketing tag query string from the cache key because it has no effect on how the image is presented to any user. So let's go ahead and click on Add Query Parameter under the Excluded Query String Parameters heading. Then we'll enter marketing tag as the value, click Done, then Save, and we'll update our service. Now that our service has been updated, let's head back over to our cat picture. We still have our marketing tag value set to 567, so let's refresh and see what happens. We can see the age header has increased from 0 and that we are now seeing a hit in the CDN cache status header. Let's change 567 to 890 to make sure that Media CDN is now ignoring the marketing tag query string. We can see the age header has increased some more, and we're still seeing a cache hit, meaning we're successfully ignoring the marketing tag query string now. This will cause our cache hit rate to increase while also reducing the load on our origin server. Now that we know how to cache successful responses and increase our cache hit rates, let's learn how to cache errors to further reduce unnecessary origin traffic. Negative caching is a feature that allows us to cache error responses received from the origin. Using negative caching is beneficial because it can lighten the load on your infrastructure during expected or unexpected downtime or issues. For example, if your infrastructure is having issues and returning a 500 error, caching the error response for even a short duration like 5 or 10 seconds can provide the origin with some much needed relief while it recovers. Let's take a look at how to set that up. On my screen, we can see the 3 route rules that we've been working with. Let's edit the catch-all rule and open up the CDN policy. If we scroll down, we can see negative caching. Let's click that checkbox to enable it. Next, we'll click on Add Policy Entry. From here, we can input the error status codes that we want to set the TTL for. For simplicity's sake, let's use 404 and set the TTL to 300 seconds. I don't recommend caching error responses for this long, but we'll do so for the purposes of this demo. Next, we'll click Done, Save, and then update the service. Now that our service is updated, let's generate a 404 error. Since we've been working with our cat image this whole time, let's try loading up an image of a dog. Unfortunately though, I seem to have misplaced the dog picture I had on my origin, so we can see that a 404 response is generated. As we look at Chrome DevTools, we can see that our cache control max age has been set to 300 seconds like we defined in the configuration. And if we refresh a few times, we can also see the age header value incrementing, as well as the CDN cache status showing a hit, indicating that the response is being served out of Media CDN cache as expected. And that's it! In this video, we learned about cache modes and TTLs, we increased our cache hit rate by ignoring a query string, and we demonstrated how to cache unsuccessful responses. Thanks so much for watching. We'll see you on the next one.